all of y'all know, I'm Haley Oyler, the president and founder of SETBP1 Society. And I also want to thank, so Jennifer Turnagel sitting right here. And then Erica Jones will join us later. If it weren't for these ladies, this would not. Oh, there you are. Okay, there's Erica. If it weren't for them, we would not be here. So, you know, when you see them, just hug them, praise them. It's amazing that this is going on. So let's see here if I quite, okay. So we're going to step back just a second. When Cole was 5, he got his diagnosis. And I know most of you, but not all of you met Cole. If you haven't, you'll meet him tonight. When he was 5 years old, it was 2.5 years before he got his diagnosis. And at that time, we were not aware of any SETBP1 researchers studying loss of function. We didn't have an organization. We didn't have a Facebook community. We had to figure out what he actually had. It wasn't clear. There wasn't a name for it. It was 13 months after he got the diagnosis before I was connected with another US family via email. And so during that time, it truthfully was pretty lonely and really hard to know like how to help Cole. And so my husband and I, a year later in 2017, we're like, we don't want this for other families. We want to be able to provide answers. We want families to get a diagnosis and have a community. And so in 2017, we formed SETBP1 Society. And here we are 6 years later, and this is Cole on the right-hand side at 11. So when we formed the organization, our mission was to connect and help families, to provide education and awareness, and then to fund and promote research. We formed a 501c3 nonprofit, so we're all volunteers. Anybody that's affiliated with SETBP1 Society is a volunteer. We have a 6-member board and a 5-member medical and scientific advisory board that helps us. I want to quickly introduce you to our board. With masks on, it's hard to see. So this could be kind of helpful. This is Eric and Cole as the vice president, Lindsay, who you saw back here with Tori, our secretary. We have Nicole Wentz, who's our treasurer, and that's her son, Colton. Elizabeth Paquette is in Canada, so she helps bring the international perspective. Her native language is French, and that's Antoine. Our board members at large are, Elizabeth, Aaron, and Trina. And so Aaron Otness is a pediatrician. So you'd seen her online, and that's John. And then Dr. Geye, Trina is there with a picture of Cole. And then myself with another picture of Cole. So that's our board. And then we have some amazing additional volunteers who help manage our social media. Janae Atkinson, which has been a little bit more silent because she had her 7th child just recently, and they're moving and they're changing jobs. They've got a lot going on right now. And then Kelsey writes our amazing press releases. So we have a really good team. We now have over 160 families in over 34 countries connected to our group. So we've grown quite a bit. This is the map. So if your child gets diagnosed, you can request for your child to be added. This is not all of our families. It's just those who've requested to be added. And I wanted to share some stats about where we are now. So we said we formed in 2017. We have 91 families in our contact registry. But as I mentioned, we have over 160 plus families connected. So we have some room to get some more families in our contact registry. And then those numbers will go up. We know of about 170 documented cases. And as families share like their genetic information, and I know more about it, those numbers will also go up. We just have to be able to verify that it's valid, basically. So the diagnosis age has averaged 5 to 6. However, access to genetic testing is improving a little. It's definitely nowhere where it needs to be, but it is improving a little. So we're seeing some more 3- and 4-year-olds coming in. So I expect that number to go down over the next year or so. I don't know what happened to that one, but it's at 7+ months. I don't know how that is what that one said. So Corey, Lindsay's little boy, is, as far as we know, the youngest individual to be diagnosed with SETBP1 HD. And then we have individuals over 60 that have been diagnosed with SETBP1 HD. As a parent, I find that very encouraging to see that there are individuals at that age living with SETBP1 HD. We have either helped fund or primarily funded 8 research projects directly related to SETBP1. We have 3 researchers, 2 in the US, Dr. Sid, and then Dr. Jessica Duis in Colorado, and then Dr. Breget van Bon in the Netherlands, who are studying SETBP1 and seeing SETBP1 patients. And we have over 30 researchers studying SETBP1. So we have come a long way in the last 6 years. And that is also extremely encouraging. And we've helped to raise over $535,000 for SETBP1 research. I'm going to go through these pretty quickly. This is just some of the ways that we help families. So we provide a website in 11 languages. We also have our quarterly newsletter. If you don't get the buzz from us, please just let me know so we can get you registered to keep you up to date. We do have annual conferences. They're just normally virtual. So this is just such a unique experience for us. And then we also provide SETBP1 online family connects for families to join. And we have a new educational webinar series called It Takes a Village that'll start back up in August, where it's sharing relevant educational materials online with you, like webinars with different people. As I mentioned, we funded research. This is all on our website, but we've funded projects in Europe, the United States, Canada, and Australia. Our main ways have been through the $1 Million Bike Ride, Giving Tuesday, which is at the end of November, beginning of December each year. And then direct donations like Facebook fundraisers, like birthday fundraisers or another way on Facebook that we get funds. People have donated stocks. That's how we've helped to fund these. We do try to be very involved with the researchers. So if publications are coming out, then we try to help make sure that we are a part of either the review process. We're actually co-PIs on a couple of projects as well. And I think I'll move through these so our main goal as an organization is to find targeted treatments for our kids. Now, and when I say treatments, yes, it could be something like a drug, but it could also be improving therapy, improving access. But that is the overall focus of our organization. And there's different ways to get involved. So I also have to put a little plug in there. We would like to get some regional patient leader volunteers to start kind of having some more regional groups. Also, people involved with Welcome Committee, of people, once they join, kind of getting a bit more pulled in. I already mentioned fundraising, donating, and then participating in research like y'all are all doing here. This is an awesome way to help promote awareness of SETBP1 HD. And thank you. And I'm going to pass this over to Dr. Chung. She is she's the principal investigator for Simon's Searchlight. And then she also works for Columbia University Medical Center, and she's amazing. And Simon's Searchlight has been with us from the beginning, which means Wendy has been with us from the beginning. Welcome. Yes.
So it's great to see everyone here, and I just want to endorse how important Haley and the board are, and you're very lucky to have Haley at the helm for things. I feel it's tough, and it's been tough on COVID, so we really appreciate you, Haley. So we could start at the top of the slide deck. I'm going to show you the update from Simon's Searchlight in terms of what we know about the conditions so far. And I will say that the work is not done. This is just sort of a progress report. And as we're going through, if people have questions, I'm fine with this being informal. I am going to save plenty of time for questions at the end if you want to sort of hold them. But if there's something that really doesn't make sense, then certainly let me know, and I'll be glad to slow down or back up the bus. Oops. So some of you saw, as I was speaking in the main room yesterday, but just to say that what I'm going to tell you about is also for the families, and it's also for the researchers. We have many researchers in the room, and for the researchers, any of the data that I'm talking about today is all de-identified but freely available, and certainly grab me afterwards if there's anything I can do to help your research. There's a huge team behind all of this. You're seeing many of them here, and many of them are actually back home still working. But just to acknowledge, there's a huge team that we put in terms of powering all of this support for you guys. And as we're doing it, we do want to hear from you. So it's your chance, whether you're here in person, grab us at any of the either times, the breaks, the meals. But we do want to hear either what's going well, but also if there are gaps in terms of other things that you think are important, questions or issues. We're here to work for you, basically. So tell us in terms of what can be helpful. Researchers for you, the same as we go through and do this. So as we're doing this, I'll just say we continue to evolve. Jennifer mentioned it, but we've been at this for 12 years, which is always sort of amazing to me because it feels like 12 months. But as we've been doing this, we realize that there are new opportunities. There are both new technologies, new ways to support our young people. And as we're doing it, we need to, in some cases, be able to be flexible, nimble, and be able to be creative. So do let us know that. And then for the researchers, there's some new technologies that are coming online about things that you can or want to do as we're understanding the condition more. So do let us know in terms of what will power your research. As we're doing this, our goal is the same as Haley's goals, which is we want to improve and enrich lives to make people be the best version of themselves and be able to just be happy, be able to be joyful. And so things that we can do to help that, let us know. We are putting out reports periodically, and we're trying to gear this exactly to families of a lay audience so that you don't have to be a scientist, you don't have to be in healthcare to understand it, as well as meetings like this that we're intentionally recording because we know everyone can't be here, and we know people will be diagnosed literally tomorrow or next week, and we want them to be able to instantaneously access those resources, not have to wait a year to find someone else who has the condition. Certainly, like I said, let us know in terms of whether or not this is helpful or additional information that you'd like to see. Many of you have been incredibly generous in upstairs being able to donate a blood sample. I'll say that for this community in particular, that's been incredibly important. Again, we de-identify all of the samples, but we're making them into cells that researcher can make into brain cells. We call these induced pluripotential stem cells that are then made into brain cells because we don't want to do brain biopsies, but we do want to study the brain and we want to study particular differences. I'll get into just a little bit of the nuance, but it ends up being very expensive. I will say that, but we're footing the bill, so you guys don't have to worry about that, but being able to make it scalable and distributable to other folks. So researchers, again, let us know if this can be helpful to you, but as we're doing this, it's a resource that will be enduring. Okay, so let me get down to business. With all of this, I'm going to say something very technical, and if it doesn't make sense, don't worry about it. But there are some researchers and some folks that will understand that SETBP1 is a little bit complicated in terms of the different genetic variants that we see within the gene. And so with this, I'm focusing today on, I think, everything that's applicable to this community in terms of being SETBP1, what we call haploinsufficiency disorder. Okay, and so what that means is, in this particular case, most people have 2 copies of the SETBP1 gene that are working equally and working fully. But for this community, instead of having 2 copies, it's if there's only 1 copy. Okay. And so in that particular case, there are different genetic variants that can all lead to functionally the same equivalent, which is having half the amount of the protein that's working. Okay. So the reason I say this is because there are other individuals with Shinsell-Gideon syndrome who have a different type of genetic variant. And there are some things that are shared, but there's some things that are different. And I know it gets very confusing for your doctors, I will say, your doctors who are not really sophisticated, no offense, but many of them don't understand the difference. And so they may try and lead you off in this direction and tell you about this, but you really want to be over here. So do tell them, pay attention. We're using the nomenclature haploinsufficiency. Haplo meaning half, and being only having half the amount. Okay, so I know that was probably a little bit confusing, but if there are any questions when you're going to your doctor, just tell them, make sure you're reading the right information. And if you're reading about or looking up Shinsell-Gideon syndrome, you're probably in the wrong area. Now, I will say that there are certain individuals who are relatively new coming to the community where we're not completely sure which community they belong in. So I will say this continues to evolve our understanding. And for the researchers, this is a priority for me to understand, is this, what's the same and what's different, and how can we get to exactly the information that people need to use for this? Okay, within this, what I've laid out here, and some people saw the same slide yesterday, is that within the research, there are many, many steps steps that go to this, but the first very important step is to get a copy of your genetic test report, because that allows us to say, do you belong over here? Do you belong over here? Or are you in the middle where we're still figuring things out? And that is very important to the researchers in terms of how they categorize things. So I know it's a pain in the rear end, but that's why we do it. And it's really important that we do that. After that, we've been doing things in terms of talking with a genetic counselor on the phone. I hope this is a conversation reciprocally where you can learn more and they can gather information from you, and maybe it's not quite so onerous. We've worked really hard to have internationally, literally almost all time zones that are reasonable covered. So we have people around the world, genetic counselors around the world working with you for that in multiple languages. And then after that step, being able to do surveys online, and increasingly we're bringing more and more languages online to make sure we don't leave anyone behind. And then, as I said, and some of you are doing it here, in-person assessments, blood samples, and we have a program called Research Match, where researchers can be able to find individuals, and then you can decide whether you want to participate in their research. But all of this hopefully to generate data that's helpful. Just very quickly, I think I mentioned this, but for the researchers, there are libraries of induced pluripotential stem cells, and we'll continue to expand that over time. And for anyone who's interested, you can grab me. But again, this is mostly for the researchers in terms of what specific genetic variants are available to be able to study. And literally the only thing that's charged is the cost of shipping you the sample. So it's very, very easy to be able to get this. Okay, this is the gobbledygook that I explained, and don't worry about the details of this, but again, mostly for the researchers, all of these genetic variations we think act in this way, where you have half the amount of the protein, and increasingly there's some new, what we call missense, or very small changes in genes that we're getting to understand better over time. And I won't go into deeply about that, but to say that there may be particular locations within the gene where those cluster, and those may be very important to understand the function of that gene. And I'm not going to go into lots of detail in the interest of time here. One of the things I wanted to celebrate, because I do think it's really important for us to realize this, is that high level, our children are generally healthy. This is really good news, and we've been seeing that over time, and they're generally happy. There are some issues. I'm not saying that there's nothing for us to work on, but they are generally just, and I can't say it just comes across obviously so much when we get to meet everyone here and see them playing and hugging and smiling. They are wonderful individuals. And so within this, that's why I emphasize here. And again, I do want to emphasize the numbers are somewhat modest. This one survey is based on 13 individuals, but they are in good health, 100% of these 13 folks. So that's great. Within that, they are generally smiley, laughing, giggling. That's the good thing, is that they are living life, right? And they are joyful individuals, and they are, I just can't say in some ways, just joyful, and I can't tell you, their spirits just exude warmth. I mean, that's the thing that I want to get across. Within this, though, there are a few things that are important, and I'm going to spend some time talking about that, because that's where we want to be able to make improvements. Within doing this, sleep is generally good for most people, but there are individuals for whom sleep is an issue. And I know when sleep is an issue, other things downstream are an issue for that, right? And so that's one of the things that we want to work on. And they do enjoy lots of different things, but I will say they enjoy things that they can predict, and things that are unexpected can be difficult sometimes and challenging. So those are some of the things that we want to be able to work on going forward. In terms of being able to, work with others and being included in activities. And again, very good in terms of family, friends, schoolmates, things like that. And in terms of being able to express their needs, some gaps. Again, I think we're doing well in terms of better technologies to be able to do that, but there's still some gaps. And I know frustrations when they can't be able to express their needs or their issues going on. Okay. So now I'm going to delve for a second into the medical issues. And again, high level is that for the most part, there aren't significant medical issues. Then again, on the numbers, this is based on 19 individuals. Okay. So first issue, and I can't tell you how excited I am to see some of our older individuals. So this is the age along the x-axis here, and this is the number of people we have at any one age. The main point that I want you to see is that most of the individuals who at least are represented in this research are under the age of 20. Okay, so I think we're getting a better picture of what it's like to be a child with this. I think the question many of you are asking, and many of you are generous enough, who have older children to help us understand is what is it like to be an adult, right? And so I think in terms of what we need to watch and be mindful of, potentially prevent or be able to monitor, we're looking a lot to the older generation. And we thank you for being so generous and helping the community understand this, because it's based on small numbers. Now, that's not to say there aren't more adults out there with the condition, right? They're out there. They don't know it. They don't know what their diagnosis is. And if there's anyone who has advice for us about how to make sure there's more access to the genetic testing that helps get the diagnosis, certainly pull me aside and tell me. But I just want to say the limitation of what I'm talking to you about is mostly what I would call a childhood experience of this condition so far. Okay, we're committed to be able to understand this over the life course, but we're limited right now in terms of our understanding. Okay, so as we're, as we're doing this, I'm starting out in terms of basically what I call above the shoulders. Sorry, this is slow. Okay, so when I'm talking, most of the manifestations that we see to me are basically in the brain. So this is basically mostly a brain and behavior condition as we think about it. And so as we're seeing this, this won't come as any surprise, but largely what we're seeing initially are problems in terms of language. And we were hearing a lot yesterday in different breakout sessions or the fireside chat. I want to make sure, I think everyone here understands, but I'm saying this for providers if they might be listening to this on video. Understanding or comprehension far exceeds ability to express, especially when we think about verbal language. And so do not sell these individuals short, right? These young people actually can process and understand quite a bit of information. I think it's up to us to find technical means for them to be able to express themselves, whether it's literally learning to speak or other ways to be able to get their thoughts across. But we do see as a major issue the language impairment. Again, I'm talking really about verbal language, speaking language impairment. I know they know a lot more than that. It's not surprised, but they're delayed in terms of their developments, and I'm going to get to that later on. And we definitely see some issues in terms of autism, anxiety, or problems with attention. Let me just show you how to read the graphs, and I know the numbers are small, but we'll be able to post these later. The number is the first one, the number out of 19, and then the percentage of those individuals in parentheses, okay? And so again, these will be posted afterwards for any of your doctors or therapists who might need this or yourselves. The good thing to me is that, and again, our community is still young, who's represented here, but within this, we're not there. What is it we're not seeing? And I think that's good in terms of being able to see other scary diagnoses. Okay, so other things that we're seeing in terms of neurological issues, we are seeing issues with muscle tone. We are seeing issues with muscle tone, and muscle tone being low is very, very common. And this is leading to some problems, and obviously why we do physical therapy, why we help in terms of core strength, being able to strengthen the core. We also see problems with coordination. So our young people may have problems in terms of being able to, whether it's fine motor movements with their hands, or whether it's things like running, jumping, going up and down stairs. Not surprising that some of those are issues. Within those are really the main issues I want to focus on. Onesie, twosie sorts of things are high muscle tone or cerebral palsy, not common is the point that I want to make. Something like a tic disorder, again, not common in terms of what we're seeing here. So it's mainly the things that I think you already know about. Again, I'm saying not surprises. I don't want you to be worried that there are other things coming down the road that we see so far. Vision is important. And the reason I say this is because literally the vision is how individuals are seeing and experiencing the world. And so if they're not seeing clearly, it makes it that much harder for them to learn and to navigate and to keep themselves safe. And so for those of you, hopefully everyone has seen a pediatric ophthalmologist or an eye doctor. If anyone that's listening hasn't, you should. I'm not saying there will be a problem, but if there is a problem, it's a treatable problem. And we don't want to miss those things that can be treated. And within these things that can be treated, oftentimes one that we're seeing is farsighted. And so this is something that's relatively easy to fix. I will emphasize a pediatric ophthalmologist for children with special needs is really important, because in terms of this, your kids are not going to be reading the eye charts and being able to say A, B, C, D. So you need to have someone who's able to actually both do a proper exam as well as be able to have them cooperate with you. But again, for the most part, these are things that for the most part are treated with glasses or corrective lenses. Rarely, there may be surgery that's necessary or patching, but again, these things are all treatable in one way or another, and it helps them just to be able to experience the world clearly. The medical issues are relatively, I would say, minimal. I don't want to, sort of dismiss them because the GI or tummy trouble, I call it, is not a joke, right? And I know when you're having problems in terms of that, it can sort of overwhelm behaviors and it can make for things being very uncomfortable. But these are things that with a good pediatric gastroenterologist, figuring out just the right diet, figuring out just the right medication that may help with either reflux or sort of heartburn or constipation. Once you get to a good place with those things, you can oftentimes stay on a much better course. So helpful in terms of being able to do that. There's not a magic wand, I will tell you. It's not like there's one single magic medication that's just going to make your life all better. And it will require some trial and error in terms of doing that. Other than that, though, there are really not so many other medical issues. What I'm saying here in terms of endocrinological issues are often problems with growth that individuals may not be. If your family is a family of 6 feet tall people, don't expect your child to be a 6 foot tall person. In general, they tend to be shorter. And one of the things I would like us to strive for as we think of standards of care is having a growth chart that's specific for SETBP1. So we can actually be able to say, not for your pediatrician to plot your children on the same growth chart as everyone else, saying they're not at the 50th percentile. I wonder what's going on. Be able to say, oh, well, for SETBP1, they're exactly where we expect. And don't worry, you're doing everything just fine. So with time, I know we'll be able to get to that. For some of the young men, there have been problems with undescended testicles. In terms of immediate medical concern, it's not immediate, but there's a very simple surgery. We can tack down the testicles, which will minimize any future risk of testicular cancer. And so it's important for your pediatrician. They're the first line of defense to see that and to see if it's an issue and needs to be treated. Otherwise, the other things you'll see here are literally onesies. So we have very few individuals. I will highlight, though, that scoliosis is one of the things I think we need to keep an eye on because that tends to come up during puberty when children are growing quickly, where the time may become curved. And we don't have as many individuals who are yet in that pubertal period. So that number may go up as we think about the life course for these issues. Okay, we've listed here the medications that people are using because in terms of medicines, these are significant enough to be problematic to require treatment, medical treatment. Attention issues, I'll point out here, epilepsy important here and sleep especially. And so thinking about those medications can be helpful. Again, I don't think there's one single medication that's helpful. It is a little bit of trial and error, but I will say in terms of attention issues, don't be afraid to use medication. I think sometimes parents are a little bit worried, but don't be afraid to do that. It can be extremely helpful in terms of educational impact. Okay, I'm going to go very quickly through this, but this is now something that many families have been kind enough to fill out what we call a developmental assessment. So these are your reports in terms of how your kiddos are doing. And the way that all of these are done is to look at age, again, along the x-axis. And normally children should be developing. They should be gaining skills over time. And so there should be kind of a developmental growth chart. And what we've done is, and I'll give credit to those in the back, Libby Brooks and Leanne Schneider, our psychologists, have plotted this out and shown us for the group, what does it look like on average the kids are developing in terms of doing. So the good news is that children are developing over time. They're gaining skills over time. They're not losing those skills once they really have them, but sometimes it takes a while to really get them solid. But the point is, this is not a regressive condition. It's not like the kids start going downhill when they hit 25. It's not like Alzheimer's. So it's mainly a matter of being able to go up and gain those skills. They're certainly slower in terms of gaining those skills. And I think what we as researchers are trying to figure out is how do we pivot that curve, right? How do we be able to move that so that we can have them gain more skills faster? So in terms of doing that, we divide these up into some very practical things about what your children, what you can expect. And so if you've got a 3, 4, or 5-year-olds and you're sitting here at this conference saying, I wonder what they're going to be like at the age of 20. What do I need to plan for? This is if we had just current state. And I want to emphasize that between where your children are now and when they get to the age of 20, for an example, I hope we will have more things to be able to help them be able to achieve more. But they are making nice progress. I think we're trying to focus on things that matter. So things that help in terms of independence, satisfaction, self-care, trying to pick those things in terms of things that are important. And so they are gaining those skills, like being able to do some things independently over time. From a social dimension, this is another thing on this particular instrument that we can see. And again, they are gaining skills in terms of being able to interact with others, being able to be safe, stranger danger and things like that take a little bit more in terms of being able to teach those, but being able to interact with others, which I think is a really important developmental skill, is certainly making progress over time. As we were doing this, this is what I was saying in terms of being able to do things like hop, skip, jump, run. Again, things are coming in over time, but they're taking a bit longer in terms of how to do that. And safety is a big issue as they're doing this. Okay. One of the last things I'll talk about are we're looking for any things that might be problems. So diagnoses in terms of behavioral problems, and the news here is good. So I want to emphasize the news that we're not coming with things of concern. This is broken down into two different age groups. The first age group is the little ones, so those that are 1.5 years to 5, and there are 11 individuals represented here. And for there to be a concern, you would need to be in this zone over here of significant concern. And you can see across all these different areas, there's nothing that's of significant concern. All of these are in the range of basically, this is what we can see in normal individuals, normal children. So there's nothing that we're seeing in terms of anything, even though you might be seeing a little bit more in terms of oppositional behavior, nothing is coming into the range of concern here. So that's good news. When we get to those a little bit older, so age 6 to 18, again, 12 individuals here, no one in the range of significant concern here. And in particular, we've been looking very carefully at adolescents, because sometimes adolescents, for those of you who have had normal children in adolescence, I have to say that's its own thing in and of itself, just regular adolescence. And so kids go through their own developmental stages there. That is one thing we're watching very closely with the SETBP1 haploinsufficiency community to see if there are things that come up. We're not seeing anything yet, but as I said, we're just starting to get folks moving into that age range. And so we'll see over time. With this, again, I take this as reassuring. It is still based on somewhat small numbers. So if we can get better numbers to know for sure that this is the case, it'll help us as we try and come up with clinical care guidelines over time. So the types of things, though, that we did see, if you look at the individual things that parents were reporting, again, this is within the younger folks up till age 5. There are some difficulties in transition, moving from one activity to the other. There are some problems in terms of attention, focus, hyperactivity. I think we knew about that. And there is just, sort of the getting into trouble, getting into things. But, I have to say that's not unlike other kids this age. So that doesn't worry me too terribly much. In terms of the older age, again, the things that I think we're seeing are problems in terms of distractibility, focus, and to the extent that it impacts the educational experience, impulsiveness, and doing things like over and over, some obsessions that we're seeing. And so helping with that, I think will help in terms of quality of life. So at the end of the day, I want to focus in terms of the positives. You're not seeing a lot of medical issues here. And I think that's a really, really good thing and an important thing. We're not seeing things like intractable seizures or epilepsy or kids that are dying or kids that are having, bad things in terms of diabetes risk or heart risk or things like that. So that's the really good news. Now we know where we need to focus our attention. We do need to focus our attention in terms of helping kiddos stay focused and develop some more of those cognitive and language skills and communication skills. And for some individuals, we're still having a certain significant portion with autism. Sometimes people tell me it's the SETBP1 type of autism, though. It's a different type of autism sometimes than your providers might be used to. And so it's important for them to know about that as well. Okay. So with that, I'm going to pause, and then we've got some time for questions. I didn't see questions as I was going on, so we've got time for questions now. And if there are things that weren't in the presentation, though, that we may need to, we've got, believe it or not, a whole team of data scientists in the back on the fly to be able to answer questions if we have to look them up from the registry. So let me pause here and see if there are questions. Or suggestions. I'm also happy to take suggestions for what you didn't see up here that you're curious about.
I think one of the things that I'm curious about, and maybe.
Okay, you got the mic. That's okay.
Thank you. Yeah, I'm curious. I'm Mike Noonan. One of the things I'm curious about, and maybe going forward in further research is, maybe as you're polling and having families or people fill these surveys out, talk about different therapies that and how many times a week they're doing the therapy, so you can see if, there's anything statistically significant that says, okay, somebody's going to therapy X days a week, where it helps with different maybe language or behavioral or occupational, different things like that. I think that would be interesting to have, especially since the subset and sample size is so small.
Great suggestion. So I'm going to, picking up some of the other things I've heard at the meeting, I think that's a great suggestion. And I think as we include that, we'll include some maybe non-traditional therapies as well, to see if any of those are working. And then, although Dr. Green Schneider is going to shoot me for this one, one of the things I'm going to ask is that more than just a yes, no, or how frequent, if you can give us some richness in terms of why you think something, or sort of insight that you have that might be beyond the yes, no sorts of things. And that would be helpful to know. And then I'm also going to make it really complicated, which is that one hypothesis I have is that starting these earlier is better. And so knowing not just what you're doing exactly right now, but historically maybe what you've done. So great suggestion.
Just similarly, it'd be good to know what medications are working, especially for the ADHD, the distractibility component, impulsivity. That would help to know if there's kind of a consistent approach to medication that would help.
Absolutely. So we have been asking that. It's something that we haven't seen a clear winner yet in terms of just, like Ritalin is clearly working for everyone in terms of this. But that is something we're definitely keeping track of.
Hi. For the older group, I just want to say that we've seen behavior issues all our son's life. And we've been on every medication from A to Z, and medications is definitely would be wonderful, if you can find something that worked. But so far, we've not quite hit that area yet. So, when you're saying that you're seeing it really mild, we've seen it just the opposite.
Yeah. I don't mean to put you on the spot and, no need to.
That's fine.
So can you give us a little bit more, because the group here has mostly younger children, and I know you've been living with this a long time. Can you help us understand in terms of what have been most impactful? And if there was something that you could treat, what behaviors would be most impactful to treat?
Well, he's definitely got the aggression. I don't know. Some of it I've always thought over the years, maybe it's the communication. He can't get his point across. As he's gotten older, I've found that he seems to know good behavior, but he also knows with bad behavior, he can get his point across. Like if he was ever in a day program, if he didn't want to be there, he'd start throwing tables, chairs, everything else. He's just, he wanted out. And, there's nothing that we can give them. We've had behavior people when they're working with them, and we have a lot of problems, not just with not the behavior people, but the people in like the group working with him. They're reluctant to try some of these options. So right now he has no place to go. We can't get him in a group home. We can't get him into a day program. And, but he's always had this aggression. I mean, we've got holes in the walls. I could go on forever. He's been in the hospital for it. Now, I have to say the last couple of years, he's probably been home with us more because of COVID. He's not quite as aggressive. A lot of you, I'm sure, have been hugged by Joe this week. But it's still, if it has to be directed towards him. If everything's going fine towards him, he's fine. But if you start talking anything negatively or not about him, or another person acts up, he's following right in their footsteps.
And with this, has there been any medication that's helped, do you think?
The one that we've had in more recent years that seemed to help a little bit has been clozapine, or sometimes known as Clozaril. But otherwise, the vast majority of them have not been helpful. The comment I wanted to make is we have often asked the physician, is there a medication that we can have at least for emergencies when he's having a really, really bad day, or we're out in a social situation where we really need to calm him down before they drag him off to the police station. And the physicians are very reluctant to give us anything. They'll say, oh, well, there's this or that. But I'm not allowed to give it to you because it can only be administered by a nurse or a doctor or something. Whereas in the past, they might give us a certain tablet of something. And I think a lot of that has to do with whatever the government regulations are in a particular community or the federal.
In those circumstances, could you give him a pill or something by mouth, or would he not be able to take him?
Yes, we just don't have.
Yeah.
We had something once upon a time and the way they would give it to me, it was not calming down and long enough for us to be moving from the situation. And now we get nothing. So if we're out of a certain situation or an off that matter, and he's having a really, really bad day, we just have to suffer through and get more holes in the walls.
So I was thinking just for time with. I was thinking for time, maybe after.
Yeah, we can talk later.
Yeah, I want to connect on that. We're going to take one more question and then we're moving on.
Hello, just it's kind of tiresome. Just from our point of view, we don't have in Puerto Rico, we don't have any pediatrician that can handle him. That does start. Okay. And his let's see how to put it. His grade level for educational grade level is like the same as my daughter, he needs to learn the numbers 1 to 10 every day. His brain is like have all this information, but do not retain it. So he learns for 6 months, everything that the grade goes. However, let's go to the summer, 2 months. And when it starts in August, the next semester is like, we need to start over again. He takes therapy every day. He have speech therapy 3 times a week, automotor therapy 2 times a week for 45 minutes. That's every week. And it's like we change him from providers 2 or 3 times because it's like you fill this hole, it's a black hole. You can give all this information, but he doesn't retain anything. He doesn't have any variants. Like I was talking with another parents over here, but his result only says SETBP1. He only have epilepsy because he was treated from 6 months old until last 2 years ago for fever seizures. So he now have Kebra and he have one vaccine so he can able be to sleep. And then he has risperidone, and that's the package from the, and also melatonin. That's the package from the before to sleep. On the mornings, he have the same thing without the white vaccine, but he needs to have the risperidone. Otherwise, he's going to be jumping all around this. So it's kind of hard to do this. We tried gastros, we tried everything. We tried is also ENT because he have a lot of infections, ear infections, throat infections. He just have removed his adenoids. And it's kind of this old thing. They try to treat him like for every symptom, but we don't have, like, for example, something that treats the condition. We need to say that, to tell them that he have this condition that provoke all those conditions so they can know how to handle.
So let me just try and generalize this for the rest of the group is that, number one, you do need to be treated as a whole person. And there are things, for instance, with treatment of epilepsy that then affect education and ability to learn and interactions with therapists. And so this is, Haley was pointing out that we are trying to, as a community, develop some centers of excellence that will think about that and take the experience of that. And I think those are going to be incredibly helpful. I'll also say that we have a couple child neurologists here at the meeting, Dr. Sid, Jennifer Bain, that if there are some very specific questions that you have, sideline them. And they do have a little bit of time for one-on-ones, but don't give up. So in terms of those therapies, although it feels like it's just a sieve and it's going right through, do not give up in terms of those. There are some things.
Oh, no, we are not giving the sleep. We go up. However, he's going to start the 4th grade, but he doesn't know how to read. He also does not know how to write his name. He have problems doing these movements. So We are using the communicator, but this could provide one who is more delayed. So we are going to try to use the iPad process. However, is that when since they all have a little big kids, they wanted to know how they're going to deal with days I started school, which is they're gonna to notice that, okay, my kid doesn't do this, although he has the condition, but they need to know in some cases, you're going to start repeating the same thing that they have on classroom. You need to do it at home every day.
Thank you. I was going to say, Dr. Sid will be a good one to connect with. Okay, so we are going to thank you so much, Dr. Chung, for your wonderful presentation. And next up, we have Dr. Angela Morgan from the Murdoch Children's Research Institute in Australia. And she also has two of her additional research assistants, Lottie and Olivia. Right here. Most of y'all have already met her. She is amazing. She's been working with our community for time, and we are just so thankful she flew in from Australia to come be with all of us today. And I will hand this over to her. Thank you.
Thank you. Lovely to be here. And it was just a wonderful day yesterday to meet people in person, because really we've just been on Zoom and filling in surveys and lots of emails, and we're really grateful for that. But there's just nothing like getting the human factor and being in the room with you. So thank you. So, as Hayley just mentioned, we have Lottie and Olivia here. Olivia has also been working with some of you on the speech tracker study, another study that we'll talk about briefly later. So thanks to Olivia for leading that. It's Lottie and Olivia's first time to the States, and it is quite a long way from where we are down in Melbourne, Australia. But they've loved coming and meeting everybody. But what we're going to talk about today, I think for those of you, many of you have had a diagnosis for some time. But if you think back to when you first had a diagnosis, really some of those first questions that you had around communication were probably how and when would speech and language develop, what factors might affect speech and language development, and then what areas should we target in therapy, or as Mr. Noonan just said, exactly what therapies are working, what's the frequency or intensity we need, etc. So these are the questions that drive us as well as clinicians, because that's our first session with all of you. These are the things that you want to know. And these are questions that we had no answers to in the beginning. We're starting to get some answers now, and we can only get those answers because you share that information with us. So thank you. But we still have a way to go. But today we're going to talk about what we know so far based on 31 families who've taken part in the study. But essentially, I just wanted to also introduce Dr. Bregia Von, who many of you will be familiar with Bregia's name, probably because she's been studying the gene SETBP1 for some time. And Bregia's a Dutch doctor, a clinical geneticist based in the Netherlands, in Nijmegen. And Bregia contacted our team because our team are very passionate about understanding speech and language in rare conditions. So Bregia reached out from the Netherlands and said, let's work together to better study speech and language. And because lots of families had shared with us that they felt communication was one of their core challenges, one of our secondary questions was also to look at whether communication was more affected potentially than, say, movement skills or social skills or activities of daily living. So that's one of our secondary questions as well. And many of you, Ruth was sad she couldn't be here. She's had a little girl, Etta, but some of you would have worked with Ruth during the project if you took part. And Ruth's also now a Dr. Braden, so she finished her PhD. So Ruth said hi to all of the families, and she would have liked to be here in person, but she was home with baby Etta. Our paper, the work I'm talking about today has been published. Hopefully all of you have a copy of the paper now. If you don't, Hayley has that and can share that with you. But we're always happy to be contacted about any parts of the paper where you might like more explanation. So as I said, we had 31 individuals take part from 8 months of age up to 23 years of age. We didn't know about Joey then, Laura. So it's really was lovely to meet Joey yesterday and have our eldest member of the community from our perspective take part. But at that time, as I said, mainly most of the children were around 8 years of age who took part. So I guess the data is more swayed to children about that age range when we look through. And because we're talking about a rare condition, we have to go globally to gather enough participants. And that's really lovely to work across many cultures and languages. We love that work. But it is challenging for a speech and language study, of course, because we have to try and translate where we can. I'm sure the Bergwerk family won't mind my saying, you know, we found someone that was an expert in Hebrew language as well. So it brings an important richness and to understand whether children from different regions and countries have the same sorts of patterns and profiles. And that's absolutely what we're finding. And it's what we find for other genetic conditions as well. Even though our languages are different, the patterns and challenges and strengths seem to be really similar across languages and cultures. Well, as I mentioned, it was a bit sort of tricky in COVID times, but actually we sort of already had to work with you remotely because we were working with people from so many different countries. So we pivoted easily to telehealth, and we could do Zoom assessments. For some of our French-speaking families, they are really great at having translators available at their local centres. So we could work together with translators where we didn't share English as one of our other languages. But a lot of the work is also looking for clinical assessment tools that might be translated and also validated in different languages. But for some of the data you'll see today, we don't have data on 31 people because the tools weren't available in those languages. So there still is a bias in the literature towards English, I have to say. And this is something that the international research world are trying to address. But that's sort of where we're at the moment. We won't have time to go through all of this today, but I'll talk about some of the main points. And we do want to say, we know those health surveys are so long, and it's why it's great to be with someone like the Simon Searchlight Foundation, because then hopefully families won't have to keep filling in all of these different forms all the time that feel really similar and that go forever. If you can have a central database and portal like the Searchlight Foundation are trying to do, it'll mean less burden for you all of your time and thinking, well, how do I remember what the speech therapy was when they were 3? I don't know what was happening. Or I think, Laura, it might have been you yesterday that made a lovely point that it depends at what time you're talking about, because children, as all of our children do, have different challenges at different times. So that was a really lovely, important point. But these were some of the tools that you kindly filled in for us. And another point I wanted to make was that often when you read papers, you might see people use the term speech and language as though they're sort of the same thing. And I think parents really get this. You guys know these are different things, but it is a bit frustrating, and it's my soapbox. Every time we talk to clinical geneticists, Lottie and the liver and I keep trying to say, please stop using the terms as though it's the same thing. And also what often happens is they just say language delay as though it's just going to catch up, and as though there's not a specific disorder or something that we need to sort of manage. And so that's a problem in the whole clinical genetic field. And we see that across all of the conditions we study. But wherever we go, that's just sort of our preaching, preaching to the converted, the families usually. But hopefully sometimes there are other researchers in the audience and we might make some change there too. So for families, you really know speech is about how we understand sounds, individual sounds, or how we make individual sounds. Whereas language is much more about words, our understanding of vocabulary. You know, do we understand what that word means? Do we use that word appropriately in context? And also our sort of sentence structure or grammar. Can we put words together in the right order? And do we understand things like past tense or plurals, you know, are our children using the right word endings in their language as well? So that's how we divide up in our papers, and you'll see when you see us talking about speech and language, this is sort of what we mean. And then the first thing we always do is think about, okay, if we're going to study speech, we want to know what are the clinical diagnoses that your local speech pathologists are looking to see so that they then know how to target their therapy. So in our paper, we look at, do children have articulation problems, which is a bit like a lisp or artic issues. You sort of think, well, all speech is an articulation problem. It's a bit difficult, but when we're thinking about this as speech pathologists, it's a little bit more very subtle things like the lisp. Phonological disorder, which we'll talk a bit more about. Fluency, so some children have experienced some disfluency or stuttering that seems to come and go with SETBP1, HD, apraxia of speech, and dysarthria. So in our work, if we can sort of delineate what the main clinical diagnoses are for speech and write about that, it means that when you go to see your local clinician, if they've got a copy of our paper, it sort of fast tracks you. So they know, okay, these are the sorts of issues my child might have. We can intervene earlier with the right targeted therapy. And then for language, as Wendy sort of spoke about earlier, there's the understanding of language, understanding of words, understanding of sentences, and then the expression of those. And then also social language, which is really interesting as well in the children in this community. So what we found were that of the 31 children, about 2/3 of children started with quite a verbal trajectory and continued on with that verbal trajectory. And then about 1/3 of children were less verbal. So there's a term often used in the literature, minimally verbal, which means you might have less than 30 spoken words. That's sort of one of the definitions, but people slice and dice that definition differently. But what we're going to talk about now here is for the children who did get first words, you know, sort of early on and continued verbally, what that trajectory looked like. And then we'll talk about the children who were more minimally verbal. So for the children who started with a verbal trajectory, around 1 in 5 children actually developed first words around 12 months of age, which is quite typical. But the majority of children developed first words at about 18 months to 2 years of age. So a little bit, the trajectory shifted a little bit. Then, as you know yourselves, in the preschool years, really hard to get each new word learned. It took a lot of effort in the early preschool years, a lot of intensive therapy, but increasing the vocabulary, increasing your knowledge of words and use of words. And the speech diagnosis that was most common was childhood apraxia of speech. So that's what that CAS stands for. So childhood apraxia of speech in 80% of individuals, which is a really high percentage. And apraxia is a condition where, as Wendy was talking about, these are sort of neurological speech and language challenges where your brain can't really quickly and automatically plan and program how sounds should go together and get the movement plan out for how those sounds go together. So we need lots of practice to get the plans working, get the brain telling our lips and tongue what to do. Because the children might know the word, but their brain is not getting the right signals to quickly produce that word like other children do, sort of automatically just start to speak. For our kids, they need a lot more repetition and practice. It's called a speech motor condition. That sort of speech planning and movement that we have to work on. But also half the group almost had a phonological problem, and that's understanding the sounds of our language and the patterns of our language. So for example, pig and dig, they vary by only one sound. And that's understanding, oh, if I put a p on that word, it's a pig. If I put a d on that word, it means digging. And so you see how one single sound carries all that meaning. And so for some of our children as well, that was an area where we needed a bit more work. And the reason I emphasize that is because that's a really important skill, the literacy development, because we know we sound out words, that's how we learn to spell. So already that's a really important area, because often in therapy, we're so focused on getting out the right sounds and practicing, getting some words. We want some verbal speech, and we forget about thinking about teaching children sound awareness about what these sounds mean in our language. So we sort of have to make sure in our therapies that we're addressing both areas. We had a nice conversation yesterday with one of the families that for their child, people are focused on their sound-based literacy learning for so long, and it just doesn't seem to be working, whereas learning whole words has been working more effectively. And that was a fantastic conversation to have, because these are our questions. Do you keep trying to learn a skill sometimes that's really difficult? Or are there compensatory pathways and other pathways we can use where the child might actually be better at learning in a different way? So that's sort of our next phase of this research, is to, as Mr. Noonan nicely said as well himself, what is working for you? You guys, again, the experts in knowing what's working, what doesn't seem to have been working, and then us trying to build targeted trials that are nice and experimental, good science, to see what does seem to be working. Oh dear. What happened there? Okay. And then, so moving on from that 2.5-year preschool sort of period, when do children get sentences? Well, we had sort of two groups of children in the verbal. Some developed sentences combining words 4 to 5 years of age, and others at 6 to 7 years of age. It doesn't mean that it's really easy to understand and really clear, but you're starting to combine words together. And most younger children, or typically developing children, would develop first words or first sentences combining words about 2 to 3 years of age. So again, the trajectory shifted, but people are improving, children are continuing to improve. That's what's most important to take away. And then at around 7 years of age, sometimes the apraxia seems to improve. So children's accuracy, getting the right speech sounds, improves, but you might hear a bit of dysarthria. So that's just where there's a lack of clarity. So the sounds are more accurate, but there's a little bit of lack of crispness and clarity to your speech. And if you remember what Dr. Chung was saying, and yourselves, there's that hypertonia, so the muscle weakness, and that's what's contributing to the dysarthria that is there once you get the speech sound accuracy. But that's okay, it's just like working any muscle. If we don't go to the gym, then we're not going to be improving and being, our physical health. And for talking and for speech and dysarthria, the best thing is to keep talking and keep using our speech. And there are some targeted therapies we could now try for school-aged children who do have that dysarthria that we would like to trial that might be helpful, sort of computer-based therapies. So we could do those even though we're not in the same country. And then literacy. So as I said, literacy continues to develop, but we're still trying to find out what are the best models of literacy development. It's often one size doesn't fit all, which is the other tricky thing. So we really do need to look at individual children and their strengths and weaknesses to see what is going to help them. But the really important point to take away is that there is that improvement. So just as Dr. Chung was saying, we completely agree. For most of the children, we do see that ability to improve. As I said, and I know some of our group in the audience today have experienced this, some of our children do remain minimally verbal. Okay. Some of the group that were minimally verbal, so remembering less than 30 spoken words, were quite young, and so still potentially developing verbal speech, but there were some children up to 11 years of age who were minimally verbal in our group. So we need to do much more work to understand why. Is it the type of variant that you have genetically? We didn't really find a relationship between the exact type of spelling error or gene change that people had and their outcome. So there must be other factors that we really need to study to understand that difference and variability. But what we see and what Dr. Chung was talking about and what we know from meeting all of the lovely families and children is that even if children were minimally verbal, they had that desire to communicate. And that is the most critical positive predictor we know that from other populations with speech and language, the desire to want to communicate is so important for that continuing improvement. And then we just have to work harder to work out what are the best therapies, what are the best pathways, what are the best devices. If we've got fine movement issues, maybe sign wasn't our way. So what else can we do to try and improve and enhance communication? But I appreciate we need to understand, we need to do a bit more research to unpack individual differences and what we need to do next in terms of therapy. We did find that about 15% of children actually had adequate language at the time that they were assessed on the Vineland. So for some children, language seems to be relatively intact, actually. But for the majority of children, they're sort of performing at least one standard deviation or lower than their typically developing peers. So for around 80% of children, they had receptive language problems, so problems understanding and comprehending language. And for about 86% of children, they had problems forming their own sentences and using languages. So this is language. So this is more about language, not just speech. It's interesting because whilst their speech challenges are great, I know Dr. Chung sort of said children understand a lot more, and it does feel like that, but actually usually expressive and receptive language in 2/3 of the group were quite similar actually when you test them very systematically. But there were 1/3 of children who indeed had expressive language difficulties that were greater than their level of understanding. Most of the children were in the low to moderately impaired language group, but that shows us there is great room for improvement and building upon language, because lots of the conditions that we work with, children actually have very severely to profoundly impaired language. So this is a really positive finding for the SETBP1 community. It really shows there is a substrate there to build upon. And now that we understand that, we need to just think of what sorts of therapies would be best to optimize children's language learning. We did see that children do, whilst children are very sociable, as you know yourselves, the social skills aren't always the most appropriate at that time or with their peer group. So that's an area we need to keep working on as well. But that the fact that children have the sociability and would like to communicate is really important for developing those skills. And then literacy is another huge area we need to do a little bit more work on, because absolutely the children had literacy challenges, but they were continuing to learn literacy, which was great. When we looked at was communication affected differently to those other areas of skill. So composite just means all the skills taken together from this test, combining everything. And then we've got daily living skills, socialization skills and motor skills. Communication skills were on average lower across the group. So, I mean, that's nothing new to you. Most of you have expressed that communication is a core challenge for you, but it is interesting to see that that does come out statistically. But of course, it doesn't mean that the other skills are all not things that we can also keep still working on. But it tells us there's something quite interesting about the SETBP1 gene and its impact on speech and language development. So if we start to pull all of this together, what are some take-home messages that we can use from this work so far? What we want to do when we have that question, what else impacts speech and language? Vision, as Dr. Chung said, we need to make sure our vision is optimized. Very important, obviously, for literacy, but it's amazing how at what young an age children start to look at symbols and letters, etc. So getting onto vision really soon is critical, even though we don't think about reading being a skill that you get until you're sort of at school. Attention. So Dr. Chung, I mean, I'm not a physician, but Dr. Chung mentioned don't be scared to think about medication for attention, because actually, if you can't sit and attend, how can you learn? None of us can learn when we're not able to attend. So attention underpins learning. So it's so important in this group of children and adults and adolescents. And then movement skills as well. So because of the speech motor system, and we know that the whole movement system of the brain with fine motor movement, etc., it does require extra work and a little bit of additional support, it's important to really think about those movement skills. And there is some evidence to suggest if you are physically active and very well and very fit and you're doing physical exercise, this does all feed into as well your speech motor system to a point. So it is important to keep up your movement skills, and the physiotherapy and the occupational therapy are really important for scaffolding your speech development as well, actually. As we know, the earlier the better. So we can see, whilst a few children can have adequate skills at different time points, most children do require some support. So as for everything, usually the sooner we get onto it, the better that's going to be. And don't be afraid of using communication devices early on in life, because actually they don't stop verbal speech. The evidence is it helps your language development. The sound awareness that I was talking about, those phonological skills, they're really important for literacy development. But it is true that we need to work out what are the best forms of literacy therapy to support the children. Maybe there are compensatory routes and whole word approaches, or different approaches might be better. We're not sure yet. That's something we need to look at. But the best evidence for now suggests you should work on these phonological awareness skills to support literacy development. Speech motor impairment, Mr. Noonan sort of saying, well, how often should you do therapy? It's like anything, intensive therapy is better if you can get it, but that depends on how many other kids you have, what else is going on in your life, what can be afforded. So you just do the best that you can, but the evidence suggests that more is better. Just like for if you're an elite athlete, the better, more training you do is going to benefit you, etc. So that's just a basic principle we can take away. And don't stop therapy just when we get the talking going, because there are the social skills, the greater language skills, the literacy skills. There is this opportunity for further development if you get the right targeted therapies and good therapists. So where you can, it's great to keep going. But sometimes you need a break from therapy. You're working on so many different things. That's okay too. You just fit that in with what other commitments your family have. But there is this generally positive prognosis for most of the children for in ongoing improvement. And just to say with Dr. Sid and Jessica and Brekya, there are these gene reviews that some of you might have seen. These are really useful for your clinician, so that, as Dr. Chung said, they don't get confused with what type of SETBP1 gene change your child has. And this can give them some guidance as to what types of therapies your child should be accessing and help you advocate for those services in your local area. Haley has a copy of this if you need. And then just to finish, as some of you have kindly taken part in our speech tracker study, our challenge of the current data is that even though we tried to look at how language changes over time, actually we just saw everyone's child at one time point. So what we need to do now is really follow children over time. So the study that Olivia's been leading for us is called Speech Tracker, and we're trying to collect data twice a year over 3 years, so that when families receive a diagnosis in the future and they come to us, we can say, oh, well, your child's 3, and of the 50 children who we've followed over 3 years of age, when a 3-year-old boy came who had this sort of profile, this is what they look like in 3 years' time. So we're starting to really improve and get data-driven information rather than saying, oh, we don't know and everyone's different, which is sort of a little bit what you probably hear at the moment. So we're trying to get data to be able to give you clearer answers. Who can take part? Anyone from 6 months to adulthood who has SETBP1 haploinsufficiency disorder, but actually we're also looking at missense variants and other variants too, other SETBP1 related disorders, as Dr. Chung was talking about, where we're still trying to understand impacts of different gene changes on speech and language. We've got children can take part with many different languages. And thank you.
So we are gonna, can y'all hear me? There we go. We are actually gonna break a little early and cut our break a little short. And thank you very much. So such a exciting information. I mean, speech and language is so impactful for all our kids. I was like, Cole what she pointed out, Cole's 11 and his speech has come a long way. But as his speech came along, like she pointed out, we then needed to work on social skills, language, grammar, and his speech therapist continues to be involved with doing that. So just touching on that, but it is 10:24. So if we can be back by 10:35, that would be great.
Okay, you guys have a response. Okay, there it is. So my name is Trina, and like Haley said, this is Stephanie. We are at Tarleton State University, which is in Central Texas. So we've been kind of chatting with everybody about where we are. We are close to Fort Worth, so that's probably all the information that you need to have. I am an assistant professor in the Department of Psychological Sciences. My training is more in cognition and experimental. I'm not a clinical person. And then Stephanie, as she'll talk about a little bit later, is clinical and school psychologist. So I can do this. There we go. Okay, so in this session, we're going to talk a little bit about what community-based participatory research is, just so that you'll kind of get an idea of where we're coming from. We're going to talk about the methods and findings that we had during the first phase of our study, and then what kinds of hopes we have for community-specific resources and future directions as we go forward. And then, as Haley mentioned, we will be around for Q&A, but that will be bumped towards the end.
So as Trina mentioned, I am a clinical psychologist and a school psychologist. So my role in this is a little bit more sort of the translational portion and also developing resources. So I'm going to be more of a back end person. She's more of the researcher, but some of the principles of community-based participatory. Community-based participatory research is a model that's really focused on partnering with the community instead of doing research on a community. And CBPR, the abbreviation, we really try to partner equally, right? And so in doing so, we have created the next phase of our research in part. She is bringing to us questions, concerns, ideas, things that we need to be thinking about and considering that come from the community so that we are responsive to all of the needs that you all have. And so CBPR, it has 9 principles. Well, it does not want to, what do you aim it at? The 9 guiding principles, which will not be shown today. The primary one that I want to focus on is that this is an iterative process, right? So in CBPR, we get feedback from you all. You all tell us what you are interested in learning more about. We do research on that, and then we give that information back to you. We develop interventions in partnership with the community, resources in partnership with the community. Then we evaluate how that's going, and then the process starts again, right? So CBPR is intended to be something that's ongoing and equal partnership. And that's really the underpinning for everything that we're doing. So we have just sort of completed data collection for phase 1. We are working on data collection for phase 2. We've met with some of you lovely families already. We have appointments with others later on in the weekend. We're collecting additional data, and we're going to be rolling that information out to you all through your community resources, but then also publishing so that other professionals, other researchers can also access that information. So it's intended to be a two-way street. And it's a reciprocal exchange. So I will go ahead, and because we are going to be brief, turn it over to Trina to share with you the results of the initial phase of research, and then we'll talk very briefly about phase 2 and what that's going to look like.
Okay, we can skip this one. All right, so
Our initial measures were selected based on the interest that we heard from the community in what the experience is of parenting kids in the SETBP1 community. So we selected some scales that we thought would answer the questions we had about that. And those include the parental stress scale, parenting sense of competence, and the dialectical behavior therapy ways of coping checklist. So many of you completed all of these over the last year or so. So we really appreciate you doing that and sharing your experience with us. And then we also had some open-ended questions. So you may have described your child with a SETBP1 difference in your own words, and you may have provided anything else that you wanted to see emerge from the research. So we asked those as well. Go ahead. And so the way that we have been recruiting participants, and we will continue to do so, is we obviously do what we need to do on our end in the university to get everything approved. And then we really depend on Haley and SETBP1 Society to get that out. So that is the conduit for recruitment. If you want to participate and you're not hearing from us, then we need to get in touch with Haley and make sure that you're looped in. So 54 parents participated in our study over the last year. The mean age was 43. 33 were from the SETBP1 community. 21 were recruited for comparison. We recruited people who were parents of children, but did not have a child with a SETBP1 difference. And we ended up excluding those who disclosed that they had a child who had special needs, just because we didn't want to muddy the waters any with our data analysis. One thing that is really interesting is this kind of description of the community. You can see that only 4 participants disclosed that their highest educational level was high school. So this kind of highlights what has been a common theme in conversations over the last few days, that there's still a need to get more people tested. So we really think that this speaks to the likelihood that there are some parents who don't have the social capital or the economic capital to kind of push through and get things handled right for their kids and get them on our radar. So that's something that we're very eager to pursue. The participant language is varied. As everybody else has mentioned, it's very definitely biased towards English, but we were able to get some folks to participate in other languages. So we appreciated that very much. So I want to kind of slide through these. We're using the same presentation we did for the researchers, and Haley told me, you get excited about stats. Nobody else gets excited about stats. So yes, ma'am. We won't talk about the stats. So what we did find on the parental stress scale, one that was just previous, we kind of expected, just kind of anecdotally, that parents of kiddos in the SETBP1 community would experience higher levels of parental stress than those who weren't. And that is not what we found. There was not a difference, right? So what we've kind of been talking about, and conversations with you guys have helped us to flesh this out, is we're thinking that it is more of a sense of new normal, right? That whenever you complete this, I'm not stressed for me, but probably your overall level of stress is higher, right? So we're going to dig into that a little bit deeper and see where we can kind of find where we're missing. We also conducted the parental sense of competence scale. And what was really interesting here is that there was no difference in how satisfied you guys were with your parenting experience over those of kiddos who did not belong in the community. But there was a difference in the sense of efficaciousness. So even though the stress was equal, parents of the kids in our community did not feel as competent and able to appropriately parent their kids. Like they felt like they were missing some resources, or maybe not always making the best decisions, right? So that's really interesting, and we're going to continue to dig into that, and we'll give you a little bit more information about what we're going to do. We also looked at the ways of coping checklist, and just go forward to the next one, Haley. So one more. What we found here is that parents who were in our comparison group, who were not in this community, used more dysfunctional ways of coping, more maladaptive ways of coping than you guys. So I think that really, I mean, give yourself a pat on the back, right? Like, even though you may not always feel like you have it all together and you know what you're doing, y'all are making more healthy decisions in terms of parenting resources and skills than other people are. And I think that that speaks to who you are as a group. And I also think it may speak to that disparity again in people who have the resources to pursue genetic testing and things like that. So we do need to look at those features of our comparison group a little bit more closely as we move forward. So this is just kind of the summary. We want to look at where exactly parents are not feeling efficacious. Go forward. All right, and I've already talked about that. So just really briefly in the qualitative analysis, the main challenge that we identified from those open-ended questions were concerns about cognition. So to that end, the main thing that we're doing at this conference is kicking off the cognitive testing that some of you guys have already participated in, and then we'll be sending things out in the coming weeks to follow up on that and really try to find out a little bit more about what the phenotype looks from that perspective. And we did find the same things that we've been hearing through all the presentations. People describe their kids as affectionate, social and friendly, happy, and those were the really big common characteristics. Is there anything you'd like to see emerge from the research project? What we heard was education, support, and awareness. So that is where Dr. Robertson is going to fill in on our future plans. And then we'll skip through this language analysis. I do stuff with words and numbers, and you probably don't want to hear about that. If you're into it, come find me at lunch and we'll talk about it. So I'm going to pass it over to Stephanie.
So just to kind of summarize and to wrap up, the things that emerged are people are interested in learning a little bit more about what the cognitive profile looks like for kids with SETBP1. We're initiating that process this year, and we'll kind of see where the data leads us in terms of additional cognitive testing. So the cognitive testing that we're doing now is a sort of a brief snapshot looking at disparities between verbal and nonverbal for those kids who are verbal, if we can gather that information. But we're also looking at other sources of information, maybe trying to develop a better understanding of some of the characteristics of hyperactivity, impulsivity. We're going to dig a little bit deeper into that. We're looking at digging a little bit deeper into some other forms of behavioral things that we're seeing, questions about autism, sort of what are the impairments that or the difficulties that some kids are exhibiting. Are we seeing patterns in the data? So basically what we're trying to do is identify patterns, identify what it looks like to be a child with SETBP1 HD. And so we're going to be able to develop that information and maybe develop advocacy resources as well. I work with a lot of families in schools who are struggling with how to advocate for their children during their IEP team meetings, those kinds of things. And so we're looking at developing resources for that as well. And also are open to other avenues for research. So as a community, if you identify other needs, please communicate those things to Haley, as she is a part of our research team and she can help to guide and shape the research as needed. So that is it for our presentation, and we will do a rapid change and get the next people on.
Thank you, Dr. Geye. Can you all hear me? No, thank you, Dr. Geye and Dr. Robertson. I was gonna, just since I was back there, I might have missed. Did y'all mention the next phase of needs assessment as well?
Sierra, you've probably spoken to Sierra. She is our student who traveled up here with us, and she's taking the lead in the next phase, which is Wendy's assessment. So one of the things that we've kind of found is we'll be talking with parents and we're talking to Amy and ask her a question, and she'll think nobody's ever asked me that before. I bet there are a lot of other people who have never been asked that question. So we're looking at models and previous methods that have been used in special communities. And over the next months, we will be reaching out to you guys again to look at what the needs are and start to link that up with what we're seeing emerge in terms of the cognitive profile.
So Dr. Sid, can you hear me? Am I on? Yeah. Okay, how about that? There we go. Dr. Sid is coming up. So most of y'all have met Dr. Sid. He works at Boston Children's Hospital. He has been with us since I reached out to him in end of 2017. It was like basically like, will you see our SETBP1 families? And he was, and this is over the phone. Like I hadn't even met him, and he was just like, yes, I'm happy to. He is an amazing person, very easy to talk with, and we're very excited to have him here sharing with us. So, thank you, Dr. Sid.
Excellent. Thank you so much, Wendy. This is really a delight and honor to speak here. For those who don't know me, my name is Srivastava. I'm one of the child neurologists at Boston Children's Hospital. I'm interested in neurogenetics and neurodevelopmental disorders, including SETBP1. And today I'm really excited to talk about updates in our clinical understanding of SETBP1 haploinsufficiency disorder. So just to get started, some very brief introduction. As you know, SETBP1 encodes a protein called set binding protein 1. Basically, one of the functions of this gene is to help control the expression in multiple other genes that play an important role in brain development as well as development of other organ systems. In humans, pathogenic variants in SETBP1 are thought to underlie two different types of clinical presentations. Gain of function misspellings in this gene are thought to contribute to a very severe phenotype called Schinzel-Gideon syndrome, which is characterized by severe to profound intellectual disability, really difficult to control seizures, a lot of systemic and organ malformations and other challenges. In contrast, loss of function misspellings in SETBP1 are thought to underlie SETBP1 haploinsufficiency disorder, which is, relatively speaking, a milder version in terms of less severe cognitive presentation and less severe challenges overall. For the purpose of this talk, we'll focus on SETBP1 haploinsufficiency disorder. Some of the very early studies looking at SETBP1 haploinsufficiency disorder came up with a pretty simple, pretty basic phenotype or clinical presentation of SETBP1 HD. Some of these early studies describe this in association with intellectual disability, expressive language disorder, behavioral issues, as well as mild dysmorphisms or certain distinct facial features. These studies were based on some chromosomal studies, and as you can tell, this is a pretty simple, pretty basic understanding of the disorder. Of course, there have been a growing number of individuals who are diagnosed or who receive a diagnosis of SETBP1 HD, due in part to the rising demand and rising use of whole exome sequencing, which is a type of molecular sequencing technique where we look at all 20 to 30,000 genes to see, is there a misspelling in one of these genes that explains the child's or individual's presentation. So with that said, even though there have been a growing number of cases of individuals receiving a diagnosis of SETBP1 haploinsufficiency disorder, the data about the full clinical spectrum of these individuals has been pretty limited, at least up until this point. So just last year or so, I was really privileged and lucky to be part of a study that looked at a more nuanced, a broader delineation of the clinical spectrum of SETBP1 haploinsufficiency disorder. So this was a study that was led by Dr. Van Bon in the Netherlands, who is a clinical geneticist, and Dr. Angela Morgan, who you heard from today, who's a speech and language pathologist in Australia. This was a study that looked at 34 individuals with SETBP1 haploinsufficiency disorder, 10 individuals who were previously reported in the literature, along with 24 individuals who had not yet been reported in the published literature. So I'm going to go through the features of these individuals to delineate the spectrum of presentation seen by individuals who have this condition. So in this study, there were 19 males and 15 females. There was a wide age range in terms of the individuals in this cohort, ranging from 1 all the way to 73 years of age. This is a graph that just shows the different types of misspellings that were covered by these 34 individuals. Basically, the takeaway point is that misspellings were seen across the entire SETBP1 gene. There's a large number of so-called nonsense mutations or nonsense variants and frame shift variants, which we don't have to go into the technical details, but there are certain types of misspellings that were seen in these individuals in this research cohort. This is a slide that talks about overview of some of the growth parameters of these individuals. The main takeaway point is that in general, growth issues were not a major concern in terms of weight, in terms of height, and in terms of head circumference. Of course, there can be exceptions. There are some individuals who fall outside of the norm of these different parameters. So if you have a child who's affected or individual who's affected who may be microcephalic, meaning have a small head size, or may be short on the short side or underweight, it doesn't mean that it's not part of the spectrum. I think this slide just shows kind of generally speaking for the cohort, what were the major trends in terms of growth parameters. We also looked at developmental milestones, including motor development and including language development. Generally speaking, there were delays across both of these domains, consistent with global developmental delay. The average age of sitting was 9 months. The average age of crawling was 12 months. The average age of walking was close to 20 months. From a language standpoint, children were delayed in their language, with the average age of first words being close to 2 years of age, and the average age of first sentences being close to 5 years of age. This is a slide that talks about the prevalence of intellectual disability in our cohort and intellectual disability severity. Just as a reminder, intellectual disability is defined as having a full scale IQ below 70, along with impaired adaptive or self-help skills like feeding, using utensils, toilet training, and so forth. What you can see here is, I think, first of all, that there was about 17% of the individuals who did not have intellectual disability, meaning that they had IQs in the average, in the typical range. There were about 7% of the individuals who had a borderline ID, meaning an IQ that may be low 70s, high 70s, low 80s, somewhere in that ballpark. In terms of intellectual disability, there's about 30% who had mild intellectual disability, which is defined as having an IQ between 55 to 70. There was about 27% of the cohort who had moderate intellectual disability, which is defined as having an IQ between 35 to 50. There's about 20% of the cohort who had severe intellectual disability, which is defined as having an IQ between 20 to 35. I think a key takeaway point of this slide is that, number one, there is a pretty wide spectrum in terms of intellectual disability severity in SETBP1 haploinsufficiency disorder. I think another key takeaway point is that there can be normal intellect, there can be, cognition that is not in the ID range, which I think is an important concept to emphasize. A third key concept is that even among those who have intellectual disability, there's perhaps a tendency to be more on the milder side. So overall, I would say that in general, SETBP1 haploinsufficiency disorder is characterized by intellectual disability, but it may be more on the mild to moderate side versus the severe side. And normal IQ can be possible with this condition. This slide covers different types of behavioral concerns noted by the individuals in this cohort. The vast majority of the highest percentage among different behavioral concerns, the most striking concern was a concern for attention deficit hyperactivity disorder, or ADHD, or ADHD like concerns. So concerns about hyperactivity, concerns about focusing. So attention or concentration deficits were seen in about 59% of the cohort. Autism was not a common diagnosis, so autism was seen only in about 12% of cases. It doesn't mean that. I think some families will report that their child may have autistic features or some social communication challenges or socialization. In some cases, socialization can be a relative strength, but there can be repetitive restrictive behaviors as a more striking component. Anxiety was reported in about 24%. Aggression was reported in about 20%, and a small percentage reported self-injurious behaviors. Among neurological concerns, the vast majority reported hypotonia or low muscle tone. So this was reported in more than half of the cohort. Seizures were not really a huge concern. About 21% reported a history of seizures, but many of these a lot of these instances were concerns about febrile seizures. Sleep problems were reported in about 12% of the cases. MRI findings, not every child or individual had an MRI. Among those who did undergo MRI, the vast majority didn't show any major structural abnormalities, didn't show any major issues. There are 2 individuals who had concerns about myelination delay on their MRI. But again, generally speaking, MRI abnormalities are not a common occurrence, at least in our data. This slide goes through different systemic concerns. So vision issues, as Dr. Chung and others have reported, are a relatively common occurrence. So this can include things like strabismus, which is misalignment of the eyes. It can include things like myopia or vision impairment and some other ophthalmologic or eye-related issues. Hearing issues were not super common, so about 9%. About a quarter reported recurrent ear infections. About close to 20% reported sensitive skin or eczema. And then about 15% reported allergies to gluten, soy, or milk. This slide goes through different types of structural abnormalities in different organ systems. A key point is, so I've listed the specific congenital anomalies that were reported among these individuals. Ankylosing or tongue tie was seen not in 5 individuals, and then undescended testes was seen in 3 individuals. I've listed also some of the other congenital anomalies that were reported by 1 individual in the cohort. The main takeaway point is that, generally speaking, structural abnormalities in different organs are not a common occurrence for SETBP1 HD. There are, of course, some exceptions, which we listed here, but for the most part, this is not a common challenge or issue. So let's summarize the takeaway points. So first of all, I would say in general, growth is not too impacted. Second point is that the early developmental trajectory is characterized by what we would consider global developmental delay, meaning delays in multiple developmental domains, including motor skills, including language and other domains. There is a spectrum of intellectual disability that probably is skewed a little bit towards the mild to moderate versus the severe side of the spectrum. With that said, there are individuals with SETBP1 HD who do not have intellectual disability. Among behavioral challenges, ADHD or attentional hyperactivity issues are a relatively common occurrence. Among neurological findings, hypotonia is probably the most common occurrence. Among systemic issues or vision issues or eye ophthalmological issues, eye-related issues were relatively common. So I think that alludes to the fact that if it might be good to have a baseline surveillance with an ophthalmologist if you have this diagnosis. And then the last takeaway point is that structural abnormalities, meaning defects in different organ systems, meaning like missing kidneys or having heart defects or those kind of things were not a common occurrence or something to worry significantly about. So I think, the last slide here is where do we go from here? So I think we've talked about a overview of all the different salient clinical features that are possible or that can be seen in SETBP1 HD. I think we need to continue to look at quantitative assessments of the neurobehavioral profile of this condition, including natural history study data using assessments, including the Simons data and other quantitative measures. I think we need to continue to look at biomarkers, basically neurophysiological markers of disease severity, things like EEG, MRI, auditory evoked potentials, and other neurophysiological biomarkers, and see how they correlate with disease severity. Can they be predictive of outcomes? And I think finally, we need to identify other factors that can help predict disease severity or can help predict why some individuals may be less severely affected versus other individuals who may be more severely affected. And this can be in the form of looking at epigenetic factors. And for example, we're doing a methylation study in this condition, but other sort of factors, metabolomics, proteomics, and so forth, to see what are additional factors that may confer one trajectory for one individual and a different trajectory for another individual. Lastly, just to acknowledge my team, my mentors, Dr. Mustafa Sahin, Dr. Ampadori, my primary mentors at Boston Children's, the Radbound team, Dr. Van Bon, Dr. Angela Morgan from the Murdoch Children's Research Institute, Simons Foundation, of course, the SETBP1 Society, including in particular Haley and Elisa Mo, who's here with me as well to help with our study today. And of course, I think it remains the most important entity here to thank is, of course, the families, to you guys. I think I learned so much from talking to the families. It's a privilege for me to be able to learn more information from each and every one of you. And I'm just very delighted and just enthused by all the enthusiasm in this audience. So thank you.
Thank you, Dr. Sid. Our next presenter was not able to be here in person due to, unfortunately, some visa issues. So she is attending virtually. So we will see her, we'll be looking more towards the screen to see her. And her name is Maggie Wong. She's from the Max Planck Institute. She works in Dr. Fisher's lab. She'll share more about it, but she does work on some research that we originally funded back in 2019, and they've continued doing research with. So thank you, Maggie.
Hi, thanks all for the introduction and letting me present my work here today.
Oh, Maggie, can you all hear me? Maggie, we can't hear you.
Okay. What about now? Can you hear me now? No. Can you hear me now? Can you hear me now?
Thank you for your patience.
Sorry. Is it good? Sorry, can someone tell me, can you hear me well? Yes. Okay. Well, I will try to speak more loudly. All right.
Yes.
Okay. Yes. So thanks a lot for the introduction and letting me present my work here today. Like Haley said, that I would love to meet you guys in person, but there's some issue with the visa, so I can't. But it's also nice to join you guys online today. So I'm Maggie Wong. I'm a molecular biologist working at the Max Planck Institute for Psycholinguistics. So after finishing my PhD at the University of Oxford, I joined the lab of Simon Fisher to study the genetics of language. So a little bit introduction of where we are, we are located and who we are. So like I said, we are at the Max Planck Institute for Psycholinguistics, and I'm in the Language and Genetics Department led by Simon Fisher. We are located in Nijmegen in the Netherlands, very close to Germany. And this is our wet lab where we do all the experiments. And the results you're going to see a little bit in my talk today. So like I said, our department studies the genetics of speech and language, which means that we study how our DNA affects how well we can communicate to understand and produce speech and language and talk to each other. So, but why do we look at DNA and genetics? One thing you need to know is that we are all different from each other. And this difference is partly because of the genetic factors, because of the differences in our DNA. And what is DNA? Before we talk about DNA, we first need to know that our body are built with many, many different cells. And in each of the cells, we have DNA, which is a material that is existing in every single cell in our body. And it functions a bit like an instruction manual, and it has its own language, and it's written in a combination of 4 letters that you see here. And this DNA is very, very, very long. And in order to pack into one single cell, it has to wrap around and being very packed into this structure called chromosome. You don't have to remember any of those terms, but I have to go through a little bit of the background and the terms that you will hear quite a lot in the talk in order to follow it. But I'm going to not talk too much about the technical details, but there's few key terms that you need to know in order to follow. And so the next thing to know about is a gene. What is a gene? So SETBP1 is a gene, but what is that? So actually it is part of your DNA and that have a certain pattern. And these genes, for example, SETBP1, some of them can give instruction to make a protein. A protein is something that inside a cell that can do its job in it. So that will control how well we function, things like that. And each of us had 2 copies of the genes. So each of us, for example, have 2 copies of SETBP1, and we get 1 copy from each of our parents. So we get 1 copy of SETBP1 from our mother and 1 copy of the SETBP1 from our father. And how do we get that? So we have an egg from our mother, we have a sperm from our father. And when they come together, they become 1 cell. And cells have to multiply, 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 and at some point to make many more cells to form our body. And during this process, DNA in our cells also have to copy itself so that every single cell also has a copy of DNA. But during this process, it can sometimes randomly introduce some changes to the DNA sequence, and that's what we call DNA variation or genetic variation. And this genetic variation can be very, very big, or it can be very, very small as well, only affecting a single letter. And it can be very common that you can find in a lot of people, or it can be very rare that it can only be found or even in a single person in the world. And these DNA changes can either be inherited, which means you get it from a parent, or it can randomly arise during the process of DNA copying itself. And this is what we call de novo. And most of the variants found in SETBP1 are de novo. So you don't find them from, it's not inherited from your parents. So, and all of us, each of us have many, many, many of these genetic variants. So we are all different. All right, okay. We covered the basics. Now we can move on to gradually talk about SETBP1. So, and today we're going to focus more on the rare variants that has very large effect that cause something called monogenic disorder, which means, for example, the very rare DNA changes in SETBP1 that can already cause some very obvious effects and cause, for example, haploinsufficiency disorder. And we can see clinical representations in the individuals with these SETBP1 changes. And how do we find these DNA changes? And with the new DNA sequencing method that you probably hear before already when you talk to your clinical geneticist or a clinician or your GP or clinicians. So what we do usually is to regroup a number of individuals with developmental speech or language disorders, and then we screen their DNA. And then in that way, we can find the very rare DNA variants. And so far, what we've found, I want to go back one slide, yes. So far, what we found, the genes we found in these individuals are very important for early human brain development, including SETBP1. But the roles of SETBP1 among other genes are still not very clear. And also it is not completely understood how do the genetic variation I just mentioned can eventually cause, for example, SETBP1 haploinsufficiency disorder. And today I'm going to tell you how we can study that in the lab. Before that, we're going to go through a little bit about the genetic variants and what it actually means in your DNA and in your cell. Although Dr. Sid already briefly mentioned it already. So first we have our schizoid syndrome, SGS, which is caused by missense variants at the very critical region in the SETBP1 protein. And it's only affecting a very, very small portion of this region, which is very important for the cell to clear away the SETBP1 that is already used. And when there are this kind of variants located in this critical region, SETBP1 protein becomes more stable. So over time, there will be more SETBP1 protein in your body, in your cells. And these kind of variants cause, like Dr. Sid already mentioned, very severe clinical phenotypes in the individuals that have these variants. But if I can go to the next slide. Yes, but other kinds of SETBP1 variants, for example, that leads to, for example, SETBP1 haploinsufficiency gives a much milder clinical features compared to the SGS. And SETBP1 haploinsufficiency is caused by certain genetic variants, for example, deletion that is only removing SETBP1, or something that we call truncating variants, which means that the variants will make SETBP1 not, there will be less SETBP1 protein. So remember, we have, each of us have 2 copies of SETBP1, and these SETBP1 variants will only happen in 1 copy of SETBP1. So the other one is still functional, which means that in the end, we have less SETBP1 protein. And that's why it's called SETBP1 haploinsufficiency, also SETBP1 HD disorder. Go on to move to the next slide. Yes. So you already heard from Angela and Dr. Angela and Dr. Sid today about the very recent 2 studies that are led by Angela and also Dr. Brecher van Bon that we also contributed to. So from these two studies that we know that SETBP1 HD gives a very, very diverse disorder, and speech and language deficits is one of the very central feature in this disorder. But so far, it's still not clear what SETBP1 does during the early brain development, and also in the end, how do all the variants that I just mentioned can lead to the phenotypes that we see in these individuals, and why is it so diverse? And actually, we can study that in the lab, and I'm going to tell you how. So in order to do that, we make use of the latest development of cell culture methods by growing cells in the lab. So you're looking at brain organoids. What does it mean? Some people also call it a mini brain. So what are they? It is a 3D structure that is composed of many different kinds of cells that you also see in the brain, and they are growing in an organized layer, which is very similar to what you also see in human fetal brain. That makes it a very good tool to study what's happening if there's less SETBP1 protein in the brain. And how do we grow this mini brain in the lab? So now we have to take one step back, because first we actually need cells. So we get the cells from people. It can be skin cells, it can be from cells from your urine, it can be cells from your blood, and we can magically make them into something called induced pluripotent stem cells, or just call it stem cells. And these cells are very magical. So if you give them the correct cues or hints, it can become different kind of cell types or tissue that you also find in your human body. And in our case, we want to make them into mini brain, or so-called brain organoids. So we have our iPS cells, and then we let them grow like a ball of cells. And gradually, this ball of cells will grow and grow bigger and bigger, and then the outer ring will expand and form these kind of bulges. That's something we also call a ventricle. But what is in these ventricles? What is in these bulges? If I can move to the next slide. Oops, too much. Yes. So if we cut the brain organoid open like this, and if we can use a method to label the representative features of these organoids, and you can see that actually each of it is one cell. You can see that these cells are organized in different layers. That is also very similar to what I just showed you in the human fetal brain. And in blue, you are looking at the precursor of a brain cell, and in the orange, you're looking at a more mature version of a brain cells, which means that we can use this model to study what happens if there's less SETBP1 protein in the system. Okay, so now we have a cellular model that can mimic the human early brain development event. How are we going to study the effect of the SETBP1 variants that we found? Again, we have the stem cells without the DNA change in SETBP1, and we call it a control. And we also have the cells that have the SETBP1 mutation in it, and that's what we call a mutant. And together, these cells, we would differentiate them or make them into mini brain, and we can compare the differences to find out what are caused by the disruption of SETBP1. And to get the control cells, like I said, we get from a donor, or we get from a parent that doesn't have the SETBP1 mutation. And how do we get the cells that is with SETBP1 mutation? If I can. if the slides want to show up. Yes. There are two ways. One way is that we can actually make them in the lab. So we can make use of something called a molecular scissors. And that molecular scissors is going to cut your DNA. And your cells is going to try to repair your DNA. And during that process, if we only target SETBP1, then we can remove SETBP1 so it's not there anymore. And we can also get cells from the individuals that already have the SETBP1 mutation. And using this approach, we can look at what the SETBP1 do during early brain development, and also find out what are the pathways that are different compared to the control. And first, I'm going to talk about how we do that, make that in the lab. So again, using the gene editing method with the molecular scissor, we can make stem cells that has, remember I talked about the 2 copies of SETBP1. We can make it only missing 1 copy of it, which is, so you still have 1 functional copy of SETBP1, or we can make it missing both copies of SETBP1, so you don't have any SETBP1 in your body or in the cells. And we make them into organoids. And you can see that when it's in the control condition with both copies of SETBP1, it grows like a typical mini brain in the lab. But if there's less SETBP1 from the gross morphological overall, it looks still kind of similar to when there are 2 copies of SETBP1, but inside there's a little bit of difference, but I'm not going to go into too much details in it today. But if you don't have any SETBP1, it looks completely different, and it shows a very, very striking differences if you just compare to the other 2 conditions. And at the moment, we are at the lab trying to find out what caused these differences. I'm trying to go to the next slide so that I can show you how. Sorry, the internet is a bit unstable. Yes, and so in this way, we can look at what causes the difference of the SETBP1. And like I said, we're also getting cells from the individuals that have already the SETBP1 HD disorder. And at the moment, we have made stem cells from the cells that we got from 3 different individuals and their sex matched parents as control. And we're doing the exact procedure for these cells as well, like what I just showed you, so that we can understand what is going on and what are the pathways that are affected by these variants that we have here. If I can move to the next slide. Very sorry. It might happen in any second now. Oh. Yes. So that was the slide that I wanted to show you, but it just skipped it. If I can show you again. Anyway, so we talk about SETBP1 HD disorder, but I want to change a little bit of the focus to talk about, because we also know that apart from SGS and SETBP1 HD disorder, there's also, other missense variants that are not causing SGS, but they are a bit outside of the critical region that we just mentioned, leading to SGS. And in 2017, Rocio, who was one of the PhD students in our group before, identified that there are several, 3 of the missense variants outside of the critical region that are causing atypical SGS that you probably, quite a lot of you already know about. And over the years, we found actually there are more of these missense variants that are also outside of this critical region. And very recently in a medRxiv preprint that together with Raphael van Boon and also Angel Morgan, that we together look at the genotype and phenotype association, trying to link how these missense variants are causing the very big differences between the clinical features that we see, and also to find out which of these variants that we've so far seen are actually damaging or can be causing a disorder. So Raphael van Boon did the clinical phenotyping, and also Angel Morgan led the speech phenotyping, and I did the functional follow-up using cellular assays for some of the variants. And what we found in this study is that these variants actually cause a very variable developmental syndrome, both clinically and also in the cellular assays that we see. And in general, these individuals have lower speech and language ability, but all of these features only partially overlap with the classical SGS that caused by the variants within the critical region, and also only partially overlap with the SETBP1 HD disorder that I just talked about. And with the cellular assays, we've shown that there's a loss of function mechanism that is actually independent of the how much of the SETBP1 protein is in your cells or in your body. And we are at the beginning of understanding what is the spectrum of these SETBP1 variants, and also the related disorder that they causes. And so the study I just showed you was use a relatively high throughput way to screen a number of variants, but still we don't know exactly what are the downstream pathways that are affected and how is this changing the brain development. So then one of the next steps is that applying the same approach that I just explained to you, using mini brain or so-called brain organoid to study what are the effects of these missense variants that are outside that critical region. And by combining with the phenotyping of the clinical and the speech features, what we're trying to do is to try to first understand what are the roles of SETBP1 during the early brain development. And second is to find out if there's any common pathway or difference in the pathway that are involved in different kinds of SETBP1 related disorders. And how is it in the end giving very different phenotypic features that we see. And hopefully with that, we can improve or aid diagnosis so that we know better which kind of variants are causing which kind of disorders, and also try to use the information we get to inform better patient care. And hopefully in the end, we can identify some target that we can try to develop a treatment for the SETBP1 related disorders. So with that, I'd like to thank the head of department, Simon Fisher, for letting me do all of this study, and also everyone that contributed to the project, and all our collaborators, and of course the SETBP1 Society for funding part of the studies that I just showed you today, and also of course for your participation. Without you, it will be impossible to do all this. So thanks a lot.
Can y'all, yep, hear me now. So if if the presenters wouldn't mind coming up here. And then that way we can direct questions directly to them or to Maggie. One thing I wanted to touch on Maggie's presentation is we're at SETBP1 Society kind of moving a little bit of a shift of saying we support families with SETBP1 HD and related disorders. And that is to cover that extra bucket that Maggie was talking about at the end. So just to reiterate, we have SETBP1 HD, which we know is loss of function, less protein. Did that go away? I think it did. And then we have Schenzel-Gideon syndrome isolated to a very specific region. And then we have other mutations along SETBP1 where we don't really know as much of what it's doing. And we're kind of referring to that as SETBP1 related disorders. And so Maggie and some other teams are also focusing on making sure we better understand that bucket as well. We want to understand any mutation that we have along the SETBP1 gene. Okay. Well, it was on, and maybe it, how about try this again? Well, yeah, there were two mics. Can y'all hear me now? All right. If there's the other mic, we will bring that one up there as well. And then that way we make sure they have a mic and then I can pass this around. So if you have a question. Yes. Okay. If you have a question, please raise your hand and I will bring this out to you. Any question? Okay, thank you.
So my question is about insurance. So thinking in a sense like if perhaps my daughter could have the need for more therapy, and if maybe our provider doesn't have enough data or doesn't know necessarily how to push for us, or maybe the insurance doesn't even know enough about the disorder on our capability of, could we refer them to someone, or is there perhaps a resource we could point them towards?
Good question. So I think there's a couple of answers. Sid, do you want to take this one, and then I can also augment on that one?
Wait, okay, this is working.
Yep.
Okay, yes. So just to restate the question is about insurance, and are there labels or diagnoses that can allow further services? Is that kind of the gist of the question? Yeah. So my experience has been that when it comes to, I'll talk about the United States, but obviously it's going to be different depending on which country you're from. So within US healthcare, if a genetic diagnosis, in my experience, rarely provides additional services or allows additional therapies or opens the doors, insurance companies don't know SETBP1, they don't know IP2, they don't know insert any genetic disorder, and I don't think that they care. And it's true. I think of all the different neurodevelopmental diagnoses, including intellectual disability, cerebral palsy or CP, autism spectrum disorder, communication disorder, ADHD, and so forth. Of all of those different neurodevelopmental diagnoses, the one that does perhaps that could potentially open the door is an autism diagnosis. And that's because so certain therapies, including ABA therapy, are only paid by insurance in the United States with an autism diagnosis, despite what the physician says is medically indicated. If I as a clinician say, I really think ABA therapy or insert whatever therapy, hippotherapy or aquatic therapy or physical therapy or whatnot is indicated, it's an uphill battle, and it may or may not work. But for ABA therapy, autism diagnosis is what allows that type of therapy. And I think also schools kind of, when they hear about an autism label, they in their mindset, they think, oh, all hands on deck, we know what to do, full intensive supports and services, especially during the early years of life, et cetera, et cetera. And for better or worse, that's kind of the way my experience has been. Obviously, I think it will differ depending on clinician and depending on state and so forth. Sometimes the label of CP or cerebral palsy, so if there's significant motor impairment, and the label of CP sometimes may also be helpful. But again, I think in the tier of things, autism has a lot more weight in terms of getting services than intellectual disability, global delay, CP, hypotonia, any of these other type of labels.
Thank you. Thank you. Two other things I was going to say on that is also Dr. Sid, Dr. Breguet Bonbon, Dr. Angela Morgan put together a gene review for SETBP1 haploinsufficiency disorder. That is very helpful for taking to medical professionals. So if they don't really know what your child has, definitely like you could print it out, take it to your medical professional. It's only been, it's not been around that long, maybe 6 months. And it's very helpful on that. The other thing is SETBP1 has a code, I believe it's ICD 78.95. It's on our website in one of the little circulating things. You could, if you're not getting speech therapy covered, all our kids need speech therapy. I would just, throw it out there. If it's not getting covered for any reason, I would ask them to try to throw that on. So just sharing that part. Okay, next question. Thank you.
Just to clarify, see how we're going to deal. The condition is or can be defined as intellectual disability, because we have him some options for the school psychologist wanted to try him as an intellectual disability. But since we live in a territory, Social Security Administration do not cover. However, for those who live in the States, they can be able to apply for the Social Security benefits. I think it's the supplementary, and they can provide for that. However, we need to know if the condition is can be applied as intellectual disability to see if we need to move over here, or we can need to do or look for other options. And also, I noticed that some parents have variants for the condition. However, its result only shows SETBP1, doesn't have any variant. So do we need to do another gene test? Because the one they gave them, it was for 7,000 genes. The first one was for 2,000 and it wasn't exclusive. The 7,000 genes was the one who got the diagnosis. However, do we need to do it another more or another one with more genes? So just to have another clear perspective.
Sure. So I guess if I could restate some of the two questions, it sounds like one in the US for the purpose of Social Security income, disability income or whatnot, is it sufficient to say that SETBP1 is an intellectual disability condition? I think so. There are a couple of parts to it. One is that not all individuals with SETBP1 have intellectual disability. Many do, but there's a percentage that do not. So it's not universal. My sense is that there may be a need to have documentation of neuropsych testing for your child, showing what your individual's IQ is. I think that may be more necessary than stating, well, he has SETBP1 and that's an ID condition. I think they may still need that documentation of IQ below a certain range, so that would require neuropsych assessment or some sort of assessment through the school or outside of the school system. The second part is, I guess, a genetic question, meaning that if the SETBP1 variant was detected on a test that had, say, like 1,000 genes or some, not every gene, and if that variant if there's some question mark about whether that variant or misspelling is causative or not, meaning if it was labeled as a variant of unknown significance, or if there's some question mark about whether this is indeed the cause or not, then it may be beneficial to do more expanded testing, i.e. if the initial test was a gene panel, then it may be helpful to do a broader test like with whole exome sequencing that covers all 20 to 30,000 genes to see if there may be another alternative or additional explanation for your child's presentation. Does that answer your questions? Okay. Thanks.
All right, thank you, Dr. Sid. We have a question online. Misha's going to provide.
So thank you so much. This question's for Dr. Morgan. So this is a parent whose child is on the spectrum of being highly communicative. So they have, the daughter talks a lot, and 95% of the communication trouble is a flight of ideas, probably ADHD or anxiety related. And she talks subject related to words. She says the subject, but the subject's all over the place. And the parent is specifically wondering, do they need to see a speech therapist, psychiatrist, or pediatrician to help with this?
Yeah, thank you. That's a really lovely question. And that was some data that I could have talked more about today, because that's called topic coherence. So when individuals are staying on the same topic. And so we do find that children who have SETBP1 haploinsufficiency disorder do have this lovely, as she said, flight of ideas. What a beautiful phrase. And so absolutely, that is something that speech pathologists can work with. It's called social language or pragmatic language. And we can give the children pointers about all of these facts. So taking turns in a conversation, thinking about the other person. Would you like to ask the other person what they would like to say about this topic as well? How do we stay on topic? What is a topic? So absolutely breaking down and describing to the children these rules, sort of the social rules of communication that we never really explicitly get taught at all. We just need to pick up. So a speech pathologist can help with that. Also, we know it's not just children with SETBP1 haploinsufficiency disorder who have a flight of ideas. That's also something we see in children who have attentional challenges or ADHD. So from that attentional perspective, like Dr. Chung said this morning, perhaps sometimes there are medications that might help, or other approaches that could also help support the children to reduce the flight of ideas that they have, or alter that. So there was the pediatrician, the speech pathologist, and the psychiatrist. I suppose, as we've talked about today, it can be really helpful, I think, to have a psychology assessment or a neuropsychology assessment, such as that Dr. Geye is doing. So you can understand your child's learning strengths and challenges. So this morning, someone was talking about you need to repeat information many times and you feel that the child might not be learning. There are different types of memory challenges or other challenges that we could pinpoint that you might be able to then scaffold. And so some of those memory abilities and other attentional issues, these are all factors that a psychologist could help support, and that can help support the speech therapy as well. So sort of, as always, a team is best to address these issues. I don't know if you had something to add. Yeah.
Just to add to that, there are a couple of different types of psychological evaluations or psychoeducational evaluations that you all can pursue, right? And so one of those is a psychoeducational evaluation through the school district. This is for United States schools, but through the school district, where they can provide a full cognitive evaluation plus academic evaluations to really look at, like she was talking about, cognitive and academic strengths and areas for growth, and then develop those specific interventions for that IEP to address those things. And so, you know, if we're looking at difficulties with processing speed versus difficulties with working memory, those are the kinds of things that can be really helpful in developing specific individualized education plans. And so you can do that through the school, but you can also pursue and you may already know all this, right? But you can also pursue neuropsychological testing, which dives a little deeper into some of those differences. So working memory, again, the holding information in your head and being able to do something with that information later on, or processing speed, how quickly you're able to take information in and then produce a response.
Okay, so I know we all have to go grab our kids. Thank y'all very much for being here today and presenting. If you have more questions, one, I'm going to throw, you could potentially just grab them since we're here. Or if it's later, you can always send them to me too, and I can get them to them. So thank you all for attending, and it's been a wonderful morning, so informative. And let's go grab our kids and some lunch. Thank you.